Hello, I am Dr. R. K. Shankaranarayanan. I am going to present about applied chemistry, especially cyclic voltammetry, its principle and instrumentation. So, in the applied chemistry field, how the cyclic voltammetry is involved in this case of analytical tool and research and development and engineering concept, how it is going to work. So, its cyclic voltammetry is especially for only just applying power supply, just we are passing the current, that will do the reactions. It is a electrochemistry field. So, we will discuss about it, principle and instrumentation concepts. So, cyclometric is the, I already said that chemical equipment, okay, it's we can find the redox reaction. What is redox? Reduction and oxidation, both things will happen in the same reactions, that we called as a redox reaction. For example, ferrous ion, you just take it as ferrous and chromium, that ferrous will get oxidized, that will form the Fe2 plus to Fe3 plus. So, what will happen, that is called oxidation, that one electron is lost and form as a Fe3 plus ions. So, next one is chromium. Chromium is Cr3 plus, that will form from Cr6 plus to Cr3 plus. So, that is also called as a reduction. So, it is a very wide range of applications we can do, especially in the catalysis and material science, all the aspects we can do the cyclic voltammetry analysis. Just its a main concept is just what we have to do to change the potential. We have to apply the different potential that we call in the cyclic voltammetry principles. Okay. So, when there is two types of can is there, forward can and reverse can. There is can, okay, that is up and down, it is like a oxidation and reduction, it is like a cyclic form. It will go and it will go forward and it will get it back. So, it is like a triangle waveforms. We can see in the images, we could find the structure of the waveforms, how it is going, how it is working. And especially when the potential reach where the redox reaction occurs. For example, I already said that ferrous will get oxidized, okay, that will once it is reached, that potential that will get neutralized, okay, that electron transferred, that is one electron to one electrode to another through the electrolyte. Here in this case cyclic voltammetry, we used to keep 3 electrodes, reference electrode, working electrode and counter electrode. So, we used to give 3 electrodes. Okay, the result here what, how the graph we are going to plot means applied potential will give the voltogram, especially the current and applied potential. So, these are the concepts we are going to use in the cyclic voltammetry. So, the shape and position fix, there is a shape I already said, it will form the triangle shape, okay, there is the upward curve and downward curve. So, 2 curves will be there, it is based on redox potential species, what are the species involved, based on that it will get involved, and reversibility of the reactions. I already said reduction and oxidation, both things will happen. So, it is mainly kinetics and diffusion process, we already discussed about it. Okay. I already said that 3 electrodes, okay, reference electrode, counter electrode and electrode, another one is a working electrode. Working electrode means we used to keep the samples in the bottom of the samples, bottom of the electrode we used to keep the samples, that we used to take some 10 mg, 15 mg of the materials. Just what we have to do, we have to use the Nafion film, there is one polymer is there, that is acting as a conducting polymer, that we have to stick on the bottom of the working electrode. Then we have to paste the samples, we have to measure 10 mg, 5 mg, like that we have to use. We have to especially use the 4-digit balance, then only we can get the accuracy of the weight. So, these are the things we are using. Another one is instrumentation, how the instrument is working. I already said working electrode, reference electrode. Okay, just think about platinum electrode. There is the potentiometry is there. There we are using two electrode, that is one is oxidation reduction will happen. Okay, in that what we are using potentiometry, we are using two electrode. One is platinum electrode, another one is the Coulomb electrode. Okay. So, here how many electrodes we are using? Working electrode and reference electrode. Okay. That reference electrode, what is the role of a reference electrode? That will maintain the constant of the accurate potential for accurate measurements. Okay. Generally what we are using silver and silver chloride saturated Coulomb electrode. In the potentiometry, what electrode we are going to use means, we used to do mercury and mercurous chloride electrode. Okay. And another one electrode, counter electrode. Okay. That is also generally people used to call as auxiliary electrodes. Okay. Because it is what it will do means, it will balance the current. Okay. Generally what we will, I already said that platinum wire. Okay. They use that platinum wire, and electrolytic solution will differ based on the experiments. Okay. If you are taking some other catalyst or materials, it will be differ, potassium chloride and sodium oxychloride. So, why we are using electrolyte? Especially for conductivity purpose. Okay. So, that instrument we used to call as a potentiostat or cyclic voltammeter. So, the electronic device, what it will do? That will control the voltage among working electrode and reference electrodes, then measure the current flow through the working electrode. So, this is the main concept. And counter electrode, what it will do? Auxiliary electrode complete the circuit. Immediately what will happen? It will complete the reaction process. We already said reverse and backward, forward and backward reaction. That platinum wire will act as a counter electrodes. Okay. So, this is the cyclic voltammetry graph. Okay. We can see y axis current and x axis voltage. Okay. That silver and silver chloride electrode, that will neutralize the current. Okay. That upward is oxidation and reduction. So, these are the concepts are involving in the cyclic voltammetry. Thank you.